Good afternoon, my name is Arina. Me and my team are developing a system for automating HR processes. Today, I'll tell you about the ranging system for resumes and vacancies, and I'll be mostly talking about the properties that we used while developing it. I believe that relevance is something that everyone is pretty sure about. Because the first stage, attraction, implies going through lots of resumes from candidates and selecting the most relevant ones. That needs a lot of time spent by the recruiters. There are different websites where they're selecting according to strict criteria, like city, work experience, and key points. But that's not enough. Let's see why on this slide. For instance, we need to find a data scientist, a CV engineer with a senior level. What do we do if we only have the listed properties? We'll first find all the resumes that have all the keywords: Python, data scientist, etc. And then we'll range the vacancies by their work experience, right? Then people who have only recently switched their field will be shown next to heads of whole departments, which means we don't have a tool that would show any difference, showing if the person fits or not. We can only assess the relevant job experience. We need that. To fix that, we use word entry models, but that might punish people for additional skills. For instance, we have requirements for a vacancy, we see the main aspects for a CV engineer, but didn't say what their experience and work results should be. For example, a clean report or a model ready for the implementation to production. The first candidate also didn't specify any skills connected to their work results. The second candidate, however, is clearly more experienced, so they did write about it. But such approaches to word entries would make the first candidate closer to the description of the vacancy than the second, while the second candidate is more relevant for us. Also, we need to work on each resumes and vacancies and to create a vector representation. Obviously, for vacancies, we take the title, the description, and then we can form a vector representation in any of the available ways. It's harder for resumes, though. There are many different fields there, and if you want to create a vector representation from them, they're usually just stuck together. The resume, the title, the key skills, the work experience. Then a vector is built, and it's compared to the vacancies. This way, we're assessing how high the skills of a person are, and that will depend on how good the description of their skills is. So we want a system that wouldn't look at certain words. It would analyze a corpus of resumes and vacancies and learn a profile for specializations. Then for each block of resumes and vacancies, it would predict of the spread of these specializations and aggregate it, considering how much time a person spent on developing in each direction. So we need a model that would learn the spread of specializations, the ranging, a certain ranging of the topics in the text. That's why we chose an architecture called thematic modeling. So we worked with a corpus of vacancies and the tags people set to each vacancy or resume in certain specializations. We train the model to do soft clusterization. Now it predicts the spread of specializations for each block. After that, we aggregate the vector representations, considering how many months a person spent on each position. This way, we'll get a vector representation for each vacancy that would say that a person, for instance, has a job experience relevant to a sales manager and only 37% relevant to a data scientist resume. This approach will produce another set of problems, though. If we get two resumes and one person, for instance, switch to data science from sales management, another one from DevOps, right? These two candidates will be just as incompatible for the vacancy because we don't actually account for the different kind of switches. If both people come from a different specialization, it's not always the same situation. We understand that a person coming from DevOps to data science, basically switching their specialization, they are very likely to develop new skills required for the new field, for the new specialization. That makes us think that we need to build more than just a specialization ranging. We also need to learn the specialization spread and the professional fields ranging and the connection between them, which means that we need to learn certain hierarchical structure and embeddings as well. So, considering the tags set by people on professional website, we'll learn the hierarchical model that can predict 3 embedding vectors for each block. The professional field spread vector, specialization, and field. We learned the first 2 layers using tags. As for the 3rd level, we learned it without a teacher. We used a regularizer for topic selection. We should also note that it's important to pay attention to how long ago job experience was received. Obviously, a person that currently has the key skills is more relevant for us than a person who had the skills a few years ago. Like here, for instance, a person who's working in data science right now is more relevant for us than a person who used to do data science and now works in, for instance, another field. So, we need to have a mechanism that would weigh the embeddings, considering both how long a person spent on a certain position and also how long ago it happened. So it would work like a fading function that would increase the importance, the significance of current skills and reduces them for older skills. In this case, it will affect the relevance percentage. Data science will go up. A person will look more like a data scientist we know we need more than the sales manager, because for the last 2 years, they've been working in data science. And their knowledge in sales is probably slowly being forgotten. Considering everything we said, we get a system that is not built for a certain set of skills. It can create profiles for fields and certain skills. It can analyze every block separately, considering how long a person spent working a certain job and how long ago they have received a certain skill. We also account for switching from one field or specialization to another. Switching specialization is simpler than fields. Such an approach is applied to recommending the competencies of external recommended future employees. And since we are training a hierarchical topical model, we can predict more than just the spread of specializations inside blocks. We can also learn the spread of key skills for each of the directions. This way, we can use this model for the automatic vacancy builder. Getting a title and a basic key skill, we can start recommending additional skills that a candidate might need to get this position. That's it. Thank you so much for your attention. Any questions?